43 months. That's roughly how long several senior U.S. officials believed China's advanced semiconductor program would stall after the October 2022 export controls. Not collapse permanently, just freeze long enough for Washington to widen the gap. Instead, China increased domestic lithography investment, expanded mature node production, accelerated packaging research, and quietly pushed entire provincial governments into semiconductor financing mode at the same time. The sanctions were designed to isolate the system. They accidentally synchronized it. And I think that misunderstanding matters far beyond chips, because this was never only about semiconductors. It was about whether financial dominance still translates into industrial dominance. Whether controlling access to technology is enough when the other side controls scale, engineering manpower, refining capacity, logistics infrastructure, and, this part gets ignored constantly, political patience. America assumed the restrictions would function like a wall. China treated them like a blueprint. There's a sentence buried in a 2023 report from the Center for Strategic and International Studies that almost nobody outside policy circles discussed properly. The report warned that export controls only work if the targeted country cannot replicate the ecosystem underneath the restricted technology. That word matters. Ecosystem. Not one machine, not one chip, the ecosystem. And this is where the conversation gets uncomfortable for Washington. Because the United States spent 30 years optimizing for software margins, finance, and outsourced efficiency, while slowly allowing the physical architecture underneath modern industry to move elsewhere, mostly to Asia, often to China specifically. People hear manufacturing decline and imagine cheap toys or t-shirts, but the same supply chains that make microwaves also evolve into precision tooling, industrial robotics, battery chemistry, machine components, wafer handling systems, rare earth processing, and eventually semiconductor infrastructure, industrial capability compounds. Countries do not stay frozen at the bottom of the value chain forever. History doesn't work that way. China understood this earlier than most Western governments did. Back in 2015, Beijing launched the Made in China 2025 initiative. American commentators mocked it relentlessly at the time. Too ambitious, too centralized, too inefficient. Some of the criticism was fair. Several early state-backed chip funds were horribly managed. Billions vanished into politically connected dead-end projects. China burns money on bad industrial policy the same way Silicon Valley burns money on delivery apps nobody asked for. But underneath the waste, something more important was happening. A national direction had been established. Provincial governments began competing to attract semiconductor firms. Universities expanded chip-related engineering programs. State banks tolerated long timelines that private Western investors would reject immediately. Supply chain redundancy stopped being viewed as inefficiency and started being viewed as security. Meanwhile, America was still arguing internally about whether industrial policy itself was somehow inappropriate, which is a fascinating debate to have while your geopolitical rival is building fabs at continental scale. And there's another layer here people miss. The U.S. sanctions didn't just target China's ability to buy chips, they targeted the ability to make the machines that make the chips. ASML's extreme ultraviolet lithography systems became the center of the conversation because they're essential for cutting-edge production. Fair enough, those machines are engineering miracles, but focusing only on EUV created a strange illusion that semiconductor supremacy lives inside one magical Dutch box. It doesn't. Advanced chips require chemicals, polishing materials, silicon wafers, specialty gases, deposition tools, testing equipment, advanced packaging capacity, precision optics, thermal management systems, and thousands of engineers who know how to make yields economically viable. The ecosystem again. That's the part China started attacking piece by piece. Not always elegantly, not always successfully, but persistently. SMIC's reported 7-nanometer class production shocked a lot of people in Washington, not because China had suddenly caught up completely, it hasn't, but because it proved something far more dangerous to long-term U.S. leverage. Barriers were slowing China down without stopping the direction of travel. Different thing entirely. And the irony is almost painful. The United States still designs many of the world's best chips. It still dominates critical software tools through companies like Cadence and Synopsys. NVIDIA remains enormously powerful. TSMC is still ahead in advanced fabrication. America is not losing in the simplistic internet sense people throw around casually. But dominance changes character when you no longer control the industrial depth beneath the top layer. A skyscraper looks invincible right up until somebody notices the foundation shifted 3 centimeters. We'll come back to those 3 centimeters later, because the real problem for Washington may not be that China caught up faster than expected. It may be that America no longer remembers how long-term industrial competition actually works. The strangest part of this story is that America actually saw pieces of the problem coming. The warnings weren't hidden, they just arrived in separate departments, separate reports, separate industries, and nobody treated them as one connected system until the pressure was already visible. Take rare earth refining. People love saying China controls rare earths, but the mining itself is only part of the equation. The harder part is refining and processing them into usable industrial materials. That infrastructure takes years, ugly environmental trade-offs, chemical expertise, and very low tolerance for short-term profit expectations. China spent decades building that capacity while most Western countries slowly decided they didn't want the pollution, the low margins, or the political fights attached to it. Then suddenly everyone remembered that modern missiles, EV motors, radar systems, wind turbines, and advanced electronics all depend on those materials. Awkward timing. And semiconductors followed a similar pattern. Not identical, but close enough that the parallels matter. For years, the dominant American assumption was that high-end innovation mattered more than broad industrial depth. The theory sounded reasonable. Keep the advanced design work, outsource lower-margin manufacturing, maintain financial and software leadership, and use global markets as leverage if geopolitical pressure ever becomes necessary. That model works beautifully right up until geopolitics stops behaving like economics. Once national security enters the equation, efficiency rankings start losing arguments to redundancy. Suddenly, excess capacity becomes strategic insurance. Domestic production stops looking wasteful. Governments begin caring where transformers, machine tools, batteries, and wafers physically come from, instead of just whether quarterly earnings improved. China adjusted to that reality faster. Not because Beijing is magically smarter, they make serious mistakes constantly. Ghost cities, local debt problems, overcapacity in sectors that probably never needed expansion, all real. But on industrial strategy specifically, China's leadership made one critical assumption earlier than Washington did. Globalization might reverse. That single assumption changed investment behavior across entire sectors. There's a company most people outside semiconductor circles have never heard of called Naura Technology Group. 10 years ago, it barely registered internationally. Today, it's become one of China's major semiconductor equipment firms, partly because export restrictions created a guaranteed political market for domestic alternatives. The quality gap with American and Japanese firms still exists in several categories. Important point. But a protected domestic customer base gives Chinese firms something equally valuable: time to improve. That's how industrial ecosystems mature. Not through one dramatic breakthrough, through iteration, through failure, through thousands of engineers solving boring problems for 15 years while foreign competitors assume they'll never catch up. Japan did this in automobiles. South Korea did it in shipbuilding and memory chips. China is doing it across multiple sectors simultaneously, which is exactly why the scale feels difficult to process. And here's where I think Washington made a deeper conceptual error. U.S. policymakers often treated sanctions as punishment. Beijing treated them as schedule acceleration. Those are completely different dynamics. The moment export controls tightened, Chinese ministries didn't interpret that as temporary pressure. They interpreted it as proof that dependency itself had become dangerous, which meant semiconductor self-sufficiency stopped being an economic ambition and became a national security requirement. That changes how resources move. Money becomes easier to justify politically. Universities receive pressure to expand technical programs. Local officials suddenly gain incentives to support industrial projects they might previously have ignored. State-owned firms tolerate lower profitability because strategic resilience becomes the metric instead. The system starts coordinating around vulnerability reduction. America still has enormous advantages, by the way. I want to be careful here because online discussions about China usually collapse into two equally lazy extremes. China is collapsing tomorrow, or China already won. Neither is serious analysis. The US remains ahead in core semiconductor design, aerospace, software ecosystems, venture capital networks, and advanced research institutions. The dollar still anchors the global financial system. American universities still attract absurd amounts of global talent. But that's partly why this situation became so dangerous. Financial dominance created the illusion that manufacturing dependence was manageable indefinitely. Until it wasn't. There's a reason the CHIPS and Science Act passed with bipartisan urgency in 2022. Washington finally realized that relying almost entirely on Taiwan for advanced semiconductor fabrication, while tensions with China were rising, might not be the stable long-term arrangement everyone pretended it was. And Taiwan sits at the center of this entire story like an electrical transformer humming too loudly in the background. TSMC produces the majority of the world's most advanced chips. Apple depends on it. Nvidia depends on it. AMD depends on it. Data centers powering AI systems depend on it. Modern military systems depend on it. If production there stopped for a prolonged period, the economic shock would spread through the global system with frightening speed. One research estimate from Rhodium Group suggested a major Taiwan conflict could cost the global economy trillions of dollars within the first year alone. Trillions. Not recession numbers, systemic seizure numbers, which means America's industrial problem isn't theoretical anymore. It's tied directly to deterrence, military planning, inflation risk, consumer electronics, AI competition, and financial stability simultaneously. That's why this stopped being a trade dispute. It became a race to rebuild industrial capacity before a geopolitical crisis tests whether the old system still functions under stress. And honestly, I'm not fully convinced either side understands how expensive that transition is going to become. There's a detail from the original Cold War that almost never gets mentioned in modern discussions about China. The United States didn't just outspend the Soviet Union technologically, it outproduced it structurally. American industrial capacity during the mid-20th century was so deep that the country could build aircraft carriers, consumer appliances, automobiles, nuclear submarines, interstate highways, and semiconductor research pipelines at the same time without appearing strange by it. That depth mattered more than individual inventions. Because industrial power is not the same thing as innovation headlines, a country can invent brilliant technology and still struggle to manufacture it at scale, maintain the supply chain underneath it, or train enough people to operationalize it economically. Those are separate muscles. And I think this is where the current US-China comparison becomes more complicated than most commentary allows. China has scale. America still has higher-end concentration. Different strengths, different vulnerabilities. For example, China graduates vastly more engineers annually than the United States in absolute numbers. The quality varies, obviously, but volume itself becomes strategic when you're trying to brute force industrial upgrading across batteries, aerospace, EVs, AI infrastructure, telecommunications, robotics, and semiconductor tooling all at once. At the same time, America still dominates many of the critical choke points that make frontier innovation possible. Advanced chip design software, high-end research universities, venture ecosystems capable of scaling new technologies globally, deep capital markets, military R&D integration. The problem is that Washington increasingly treats these advantages as permanent laws of physics, rather than systems requiring maintenance. Empires get weird when they've been dominant too long. They start assuming gravity only applies to other people, and this is where the story reverses slightly. Because despite everything I've said so far, China's model also carries risks that are becoming harder to hide. Massive local government debt, weak consumer demand relative to industrial output, youth unemployment pressures, property sector instability after the Evergrande collapse. Some semiconductor projects funded during the state investment frenzy were borderline fictional. Empty facilities, corruption cases, equipment ordered before engineers even existed to operate it. Industrial policy can create momentum. It can also create hallucinations. The reason this matters is because Western analysts sometimes overcorrect after underestimating China. First, they dismiss Chinese capability entirely. Then, once proven wrong, they swing to the opposite extreme and assume Beijing has become unstoppable. History is less cinematic than that. China's system is extremely effective at concentrating resources toward strategic goals. It is much less effective at admitting failure quickly when political prestige becomes attached to those goals. That creates waste. Sometimes enormous waste. But here's the uncomfortable part for America. Waste inside a gigantic industrial system can still produce results. especially when the competing system spent decades optimizing for shareholder efficiency instead of redundancy. Remember those 3 centimeters from Part 1? This is where they matter. Foundational shifts in global power rarely look dramatic in real time. They appear first in procurement contracts, refinery output, shipping capacity, machine tool exports, engineering enrollment, transformer manufacturing, battery chemistry patents. Boring things. The kind of things television panels almost never discuss because nobody gets emotional arguing about industrial solvents. Then one day, the strategic consequences become impossible to ignore. Europe learned this painfully after Russia's invasion of Ukraine exposed how dependent parts of the continent had become on external energy systems. Germany, in particular, built an economic structure heavily reliant on relatively cheap Russian gas feeding its industrial base. That arrangement looked efficient for years, until geopolitics arrived carrying a hammer. The United States is facing a quieter version of that realization with China. Not energy dependence exactly, but industrial interdependence at a scale that makes rapid separation extremely difficult without damaging both sides simultaneously. And this is why the decoupling language coming out of Washington has slowly softened into phrases like de-risking, small wording change, massive strategic difference. Decoupling implies separation is achievable. De-risking quietly admits it probably isn't. Even Apple, one of the most sophisticated supply chain companies on Earth, has struggled to diversify production away from China quickly. India and Vietnam are gaining manufacturing share, yes, but replicating the Chinese ecosystem is not just about labor costs. It's supplier density, ports, tooling firms, specialized engineers, logistics speed, the ability to source components within hours instead of oceans. People underestimate how hard ecosystems are to rebuild once they cluster geographically. Silicon Valley happened that way. Shenzhen happened that way too. There's also a deeper irony underneath all this. American pressure may actually be accelerating Chinese technological independence faster than gradual competition would have. Not because sanctions failed completely, they clearly slowed access to frontier technology, but because they removed ambiguity inside Beijing. Before the export controls, China still had incentives to remain partially integrated into US-led technology systems indefinitely. After the controls, dependence itself became politically dangerous. That changes long-term planning, and I keep coming back to one question I don't think enough people ask honestly. What happens if both countries are right? What if Washington is correct that China represents the most serious strategic challenge to American power in decades? But Beijing is also correct that relying on American-controlled systems became too risky to continue. Because if both assumptions are true simultaneously, then this isn't a temporary trade conflict anymore. It's the early stage of two parallel technological ecosystems slowly pulling apart under tension. Not fully separated, not yet, but no longer trusting each other enough to stay comfortably connected either. That's a very different world from the one globalization promised in the 1990s. The deeper problem for America isn't that China became stronger than expected. It's that pressure clarified China's priorities faster than America clarified its own. Washington believed export controls would preserve technological dominance long enough to stabilize the existing order. Beijing looked at those same restrictions and reached a different conclusion entirely. Dependence on American-controlled systems had become a strategic liability. That realization changed everything. Not overnight. China still trails badly in several frontier technologies. The gap in advanced semiconductor tooling remains real. American firms still dominate critical software layers, AI hardware design, aerospace systems, and global finance. Anyone telling you the US has suddenly collapsed into irrelevance is performing for an audience, not analyzing reality. But something fundamental shifted anyway. The sanctions removed ambiguity. Before 2022, China could still assume partial integration into the US-led technology system might continue indefinitely. After the export controls, Beijing started preparing for a world where that assumption no longer held. Semiconductor self-sufficiency stopped being an economic ambition and became a security doctrine. That changes how a state behaves. Money moves differently. Universities receive pressure to train more engineers. Local governments start protecting supply chains instead of just chasing GDP growth. Industrial redundancy becomes acceptable. Inefficient sometimes, expensive, absolutely, but survivable under pressure. And survival is increasingly the metric both countries are optimizing for. That's the part I think most people still underestimate. This isn't really about chips anymore. Chips are just the visible layer. Underneath sits a much larger question. Can modern powers still build and coordinate industrial systems at national scale for decades without breaking politically or economically? China believes centralized coordination gives it an advantage there. America believes innovation and private sector dynamism will ultimately outperform state-directed systems. Honestly, both arguments contain truth. China has scale, industrial depth, and strategic patience. America still has extraordinary universities, financial reach, research ecosystems, and a culture that remains unusually good at generating breakthrough technologies. Neither side is weak. That's why this competition feels so different from the Cold War comparisons people lazily recycle. The danger is that both countries now see dependence itself as risk. That creates duplication, parallel supply chains, export controls, subsidies, strategic stockpiles, slower globalization. Higher costs passed quietly on to ordinary people who may never hear the phrase industrial policy, but will absolutely feel it in prices, jobs, and economic instability. And I keep thinking about something almost nobody said out loud 20 years ago. Industrial ecosystems have memory. A country forgets how to build things slowly, then all at once. Factories disappear one supplier at a time. Engineering cultures thin out gradually. Skills retire. Infrastructure ages. Eventually, you wake up and realize rebuilding takes far longer than outsourcing ever did. That may be the real lesson here. Not that China won, not that America lost, just that manufacturing depth, once treated like a boring background detail of globalization, turned out to be one of the central forces shaping power in the 21st century. And by the time Washington fully recognized that, China was already building around the pressure instead of waiting for it to disappear. If you enjoyed this, subscribe, because the next phase of this story won't stay inside semiconductors. It's going to spread into energy, AI, shipping, finance, and probably every major industry that still assumes the old global system is permanent.